Welcome to the last panel, Balancing Innovation and Traditional Training, Training the Current and Next Generation of Airline Pilots. I am Randy Symanski. I'm a captain and check airman with Spirit Airlines, and I'm also the chair of ALPA's Training Council, representing the training leadership from 43 of our pilot groups across the United States and Canada. Joining me today on stage, our first officer, Raymond Hicks, Manager of Training Delivery at Envoy Air. We have Captain Logan Shamoon, Envoy Air ALPA Training Committee Chairman. Captain Samantha Brown, United Airlines ALPA Training Committee Vice Chair. Captain Josh Assayag, Managing Director of Flight Standards, United Airlines. And lastly, Captain Bryan Burks, Alaska Airlines Human Factors and Training Committee Group Member. I want to frame our last hour here with one simple premise. This is not a debate between the new technologies and the old ways of doing things. This is about using the right tool for the right task and at the right time, and proving that it makes pilots safer on the line. Full flight simulators with motion and high fidelity flight decks remain the backbone of airline training. At the same time, virtual and augmented reality can expand the frequencies, accessibilities, and the repetition for specific skills if we validate that learning transfers into real line operations. You'll also hear a consistent theme this afternoon: integration and not substitution. Virtual reality and AI, they can be a powerful supplement, but we should be cautious of any claims that reduce training fidelity without a demonstrated data-driven safety benefit. We're fortunate to have panelists who bring evidence. We have line pilots, training leaders, and standards experts who are implementing these ideas right now. I won't read their bios from the stage. You can find them in the ASF app. We'll start with how one carrier has deployed VR in training and what's worked, what hasn't worked, and what the data has been telling them. We'll move to how a major carrier is evolving flight path management and professional development while maintaining simulator standards. Then we'll end with how the industry is qualifying these devices against required training and why motion fidelity still matters. We'll reserve the last 10 minutes or so for any questions for the microphones in the room or on the ASF app. Our goal here is simple. When you walk out of here today, you should be clear on where emerging tools can help, where they don't, and how we can adopt them without eroding the core competencies that keep our passengers and our crews safe. Envoy Air, one of our ALPA partners, who is utilizing VR right now as we speak. We'll put some pictures up here on the screen for this first topic so you all can get an idea of what some of this new technology looks like. So first off, Raymond. So Raymond, how is Envoy utilizing these VR training devices in its training program right now?
Hey, great question, Randy. Nice to meet everybody here. Currently, Envoy is using our virtual reality devices for both interior and exterior pre-flight training and validation.
Very good. And how has this new technology been implemented in training as a supplement and not existing training? And how has it been used or not as a replacement for full motion sims?
Very good. So I want to preface this by saying that it's not a replacement at all. It is an addition to our current FAA-approved pre-flight training. The way the footprint kind of looks right now is we have our BIA week 1. We go, new hires, and speak to them. We speak to the pilots during our management briefing, and we give the new hires access to this program. They can access it via any web browser, and they can access it from home. We want to start with this base rope level of knowledge where they can access this program at their own pace, and they're able to work at their own pace and start with that. The next portion of training would be an instructor-led class, which we have on our 4th week of systems. We have a virtual classroom with about 26 devices in it, where we have as you can see in the pictures here, all the students hooked up into one virtual environment where an instructor is physically leading them around a pre-flight. This class takes roughly about 4 hours to complete, and we do both interior, exterior, pre-flight training in that time. We also have 1 hour of free play where the students are able to boot up the program, access any modules they would like to, at their own pace, and ask any questions with one of our dedicated instructors. The last portion of it would be the validation portion of it. So during our CQMVs, we have our instructors load the program at one of our off-site facilities, and they're able to validate the students' knowledge and proficiency with the program, and then also with their ability to conduct the pre-flight. I want to say this, this is more to enhance the safety of the pilot. If we can catch something on the ground before the aircraft ever leaves the pavement, it's going to enhance our operation through and through.
Very good. So I guess the big question today is why? Why use these new technologies, specifically VR, within the training program?
Absolutely. So our Director of Flight Training, Captain Alan Hill, is always on the lookout, on the hunt for any new innovative technology that he can get his hands on to enhance our training program. And he was actually able to get in contact with a company over at a Watts Convention in Orlando, Florida, called Cole Engineering. And they were able to actually go out, to a DFW airport, Terminal B, Bravo 44, I believe it was, and physically model one of these, our 175 aircrafts through the program. So it's actually pretty cool. It's so detailed to the point where, we all know it. On the captain's side tiller, we got a little bit of paint missing because we got our sweaty palms all over it, right? So even in the program, you can see that detail in the program with the paint missing. You can find dirt specks and all sorts of stuff. So it's very, very high quality program.
And are you collecting data on this, and how's that data being used?
Absolutely. So we're capturing data at a couple different points. Right now we have our program manager of data analytics, Jeanette Barrett. She's able to capture data points. At the first level would be a survey that we have our students fill out before accessing the program, and that's kind of just getting their baseline judgment of, how much experience do they have with virtual reality, computer software, is that kind of stuff. The second portion would be after our instructor-led class. We get a post-survey from the students kind of judging now their base after experiencing the class, and then get a little bit more understanding. We've been getting nothing but positive feedback from there. It's been really good. And the last data point capture we have is a survey conducted by the instructors after completing the validation. And they're able to, talk about the program, talk about the system, any issues they may have encountered during it. And then the final capture point would be every module that's completed, we're able to capture that data and see, how many clicks the student did, how many hints the student used, and that kind of stuff.
And so where do you see this going in the future at Envoy? Where's this going to head?
Absolutely. So the future, the plan right now is we actually have flow training implemented into the program itself. So currently, the way I like to explain it is, typically being a regional carrier, we typically get, brand new flight instructors, 1,500-hour pilots. They're used to the slow pace, slow flying Cessna 172 around the track pattern kind of flying. We try to help increase their bandwidth to get them to the fast pace, high altitude, normal, abnormal, emergency, VFR, IFR conditions that you'd experience as a regional airline pilot. So what we're able to do is increase their bandwidth by introducing additional training to kind of get their base knowledge a little bit higher and help with that transition. So the flow training, as we all know, they're used to a normal read and do checklist, and now they're going to a flow and an associated checklist with that flow. The flow training is going to help increase that student's bandwidth so they could focus on the task at hand without having to,
So Logan, you've been using this new technology for a few months now, right? And the new hires have. What kind of feedback have you received from, the pilots and students with the VR that you're using?
Thanks, Randy, for allowing me to speak on behalf of the Envoy pilots and instructors. The feedback has been overall very positive from the students. They get so immersed into the program, especially in the 3D world, that even sometimes the students' feedback has showed that they didn't even realize that they were in that virtual world. They thought they were standing there by the airplane or walking through the cabin or sitting in the flight deck, practicing their flows. So the feedback overall has been extremely positive with both the instructors as well as the students especially.
Very good. any challenges or any challenges with the equipment or the headsets?
Well, when we first started this program, this has been, I believe, an 18-month, 16-month development so far. And when we first got started, they brought us instructors in to demonstrate the equipment. And as a quick example here, when we sat in the chairs the first time, they were static chairs, just like what's out in the audience. And you can move your head, but you weren't really able to pivot your body. So the company took our feedback and made the changes necessary to help improve it before we even got to the first student, where now we have chairs that are able to swivel around, where they've got more freedom of movement. But with that said, there are a few things that we have received with the feedback from the students, starting with some of the things that we can easily change over time, such as the air conditioning in the room. That's one thing that when you have all these computers running, it does get a little bit warm. So we're trying to work through and get the air conditioning to be its own dedicated unit where it can cool down the room. Furthermore, the load time, our students are able to access this program not only in the VR lab, but also from home using the online version of the software. That software has to download to the computer, and it does not cache any information. So it does take some time for it to load for the students at home. Some of these physiological things that we've been seeing is eye strain. That was probably the number one reported physiological symptom, followed by just the fatigue of wearing the headset for long periods of time, and then finally a very small percentage of nausea. Now, with that being said, this was a very, very small group of pilots that experienced this overall to the rest of the class. But we've taken some steps to address that, especially when it comes to the eye strain and fatigue, allowing good breaks in between the sessions where the students aren't having to wear those headsets for a very long time. In addition to that, if a pilot experiences fatigue or nausea, they can easily just remove the headset and go straight into the 2D world and pick up right where they left off as well.
So as an instructor, what are some challenges that the instructors or some instructor feedback you may have gotten so far?
Well, it's funny because being a regional carrier, our demographic of pilot tends to be a little bit on the younger side, whereas the instructor side, a little bit on the older side. So getting them, I would say it was a little bit intimidating for them to use the headsets for the first time. But once they got in it, they were really blown away by it. And just by the user interface that the software has, it's very, very simple. So after a couple practice sessions of using that software, I think a lot of our instructors are getting more and more comfortable with actually using it and facilitating it.
And so as training committee chairman, you are a representative as well as an advocate for your pilot group. So why is this, why are exploring these new technologies, so beneficial for your pilots?
We kind of talked about the immersion factor, and the immersion of this is fantastic, where again, that student can sit inside the flight deck or walk around the aircraft, something that they have not been able to do with training tools leading up to this point. If you look at the slides that we were showing, giving the student the ability to walk around and see what a bird strike could potentially look like, or where the gear pin actually sits in. It's one thing when you have a static photo of a zoomed in space. It's another thing where you can actually see the overall picture and where that is located in the aircraft, and being able to work on your flows in a more immersive environment versus just using a paper tiger. So our students are able to access the software from virtually anywhere in the world and practice it as many times as they want to. So they get that experiential learning, just repetition by doing and getting that kind of hands-on feel of it, which has been fantastic.
So what would you say to the carriers in the room here today who might be looking at adding these technologies to their own programs?
Well, we talked about how great the software is, and it's a fantastic tool, and it's a great tool to be used early on in their training, where they are getting introduced for the first time to the inside of the aircraft and the flight deck, getting practicing their flows and their profiles, callouts, and using the checklist. So it's great early on into their training and being able to get that first introduction to the aircraft. but there's still some limitations. You know, you can't just physically go up and have that tactile feel of manipulating a switch or push button. You don't get the sensation of movement like you would in a simulator. So we should always be using the highest fidelity of devices for those higher level stages of their training. But for something like this, it is a good introduction to where they can focus their time getting the flows and call-outs done, getting the acclimation to the aircraft. That way they have more time when they do get into our procedures training and they do get into the simulator environment, that they already have those fundamentals down to where they can now work on the next level of training, getting that higher fidelity of learning.
Very good. Next up, Samantha. So Sammy, what is United's viewpoint on, the various levels of simulations, used in pilot training?
So at United, we utilize two different types of training devices. The first is a fixed training device, and the second is a full motion simulator device. Both of these devices offer high fidelity environments for the pilots. Our training is broken into 4 phases. The first 2 being aircraft systems and procedures we do in our fixed training devices, and this allows the pilot to be in a tactile environment where they are allowed to practice their flows, call-outs, procedures, develop muscle memory, and then they can take what they've learned in the first phase with the fixed training device and transition all of that over into the full motion simulator. Then while they're in the full motion simulator, they can really hone those skills that they've learned in the first stage of training, as well as recognize, aircraft movement and handling characteristics. Both of these training devices, the high fidelity fixed base training and the full motion simulator, allow pilots to, again, just immerse themselves in that tactile environment, so they are allowed to push buttons, they're allowed to see how the aircraft is going to react, as well as the visual cues, and just establishing that muscle memory that they can then take and apply to real world operations. Essentially what this is both devices offer an opportunity for kinesthetic learning through an adaptive approach in the flight deck environment. So they're able to actually be there, touch buttons, see how the aircraft is going to react.
Right.
Randy, if I can just chime in on that
absolutely.
real quick. So obviously we are heavily invested in our flight training device strategy at United, and we're incredibly fortunate to be preparing to install our 64th flight training device at our flight training center. But we are constantly looking for opportunities to improve the environment that we are introducing our pilots and training to. We recognize that while motion platforms and the visuals on the simulators have improved over the years, we really haven't done much to change the simulator environment that we're placing our pilots into. And oftentimes we see a difference in level of performance with our pilots between the line and in our training environment in some of those high-risk, low-frequency events. So one area where we see being able to improve this is with the introduction of artificial intelligence air traffic control into our simulator devices. By introducing the same types of distractions that our pilots are going to encounter on the line, we're preparing the pilots to be more resilient for that dynamic environment that they're going to experience in the line environment.
Good. So just to shift gears here for just a sec. So Sammy, can you share how United's pilot training program has evolved with the guidance from the Flight Path Management Advisor Circular?
Yes, happy to. So flight path management is the planning, execution, and assurance of the aircraft trajectory and energy state, both in flight and on the ground. Essentially, it's the highest safety priority for crews. To address the advisory circular, a few years ago, United implemented our Flight Path First initiative, which was our training response to flight path management. From there, we have also introduced a CRM strategy for our crews. It is a check path call-out. And what it is, if any pilot notices a deviation from the intended flight path at any time, that pilot can announce check path. As I said, this is a CRM attention management tool. use to bring both individuals back into the flight deck. So somebody says check path, eyes forward, what is the pitch, what is the power, what is the path of the aircraft. It is a way to establish a shared mental model between our crews, looking through the flight director in case it is giving you erroneous or incorrect information, and just ensuring that the state and energy management of the aircraft is the top priority.
Very good. Can you speak also to the professional pilot development program and how this program supports professionalism and mentorship at United?
Yes, so at United, we have made a conscious choice to really set the bar high for professional pilot development. Our PPD course, per the advisory circular, is a 1-hour course delivered to captains only to address topics such as professionalism, leadership mentoring, and conflict resolution. United saw the importance and an opportunity in PPD, and we deliver a 5-hour in-person facilitated course to our entire pilot group, recognizing that all of these topics, professionalism, leadership, and mentoring, are a shared responsibility in the flight deck. This course was developed with both United and ALPA in the room. We use de-identified United events and safety data, and each course has built upon the last when we deliver to our pilots. So,
Do you have any, like a example of one of the modules? Can you give us an example of one of them?
Sure. So all of our modules are 45 minutes to an hour in length, depending on the facilitator. And each module is broken down into certain topics. So there will be a specific professionalism model, a specific mentoring and leadership model, conflict resolution, etc. And as I said, we use de-identified United events and safety data to present to our crews. And the reason for that is to highlight that, this isn't just an industry thing. This is an us thing. This is an everyone in the room thing. So we use these events to really turn PPD into a true safety experience, so our crews can walk away with tools and resources that they can then apply on the line to address all of the objectives in the advisory circular. We don't just PPD is not just a checkbox for us to meet the regulatory requirement. We really went above and beyond, recognizing, again, the importance of the professionalism and leadership skills in the flight deck.
So, and we'll skip over to Josh now. So Josh, how does United focus on maintaining the highest level of safety, in training, while also keeping, an open mind about all the new, technologies that are coming down the road here?
Yeah, Randy, thank you for that. If I may, first, thank you, Randy, for facilitating our panel today, and I want to thank the ALPA leadership for the invitation to participate in the panel. I think that's indicative of the positive collaboration or collaborative relationship that we enjoy with our ALPA partners at United. So at United, we are really diligently focused on taking a deliberate, data-driven approach to evaluation of our entire training program. This includes incorporating data from all of the various streams, whether it's our SMS program, FOQA, continuous LOSA, or training performance metrics, to ensure that the decisions that we're making about our training programs are evidence-based and they're not based on assumption. That allows us to proactively address risk before it manifests itself in the operation, as well as reactively respond to some of the trends that we're seeing in the operation. That said, we obviously understand that we have to remain flexible and adaptable to the changing environment, and we're always looking for new methodologies, philosophies, or technologies to implement to enhance the training environment for our pilots. And whether that is looking at adaptive learning or advanced delivery methods or even new simulator technologies, we're always looking for that opportunity to build a more resilient, prepared pilot for the dynamic flight environment that they're going to encounter out on the line.
So as a managing director, how do you include your ALPA partners in developing your training programs and incorporating this?
Yeah, as I mentioned, we're incredibly fortunate to have a collaborative relationship with our ALPA partners and the ALPA Training Committee. And I think it's a recognition on our part that collaboration is not just about advising ALPA at the end of training development. It's about including them through the entire process from development all the way to delivery to ensure that they have a say in the training that's developed. We don't see this as a contractual requirement. We see this as an essential part of the training development. And we recognize the perspective that the subject matter experts from our ALPA partners bring to the table. And even more so, we believe that this builds confidence from our line pilots in the training that is being developed, because they understand that their perspective is being represented in the development and increases the buy-in and the training that they're receiving, creating a better product for our pilots.
So all these enhancements, at United Airlines that you've implemented, have you noticed any, notable safety impacts, directly to your line operations?
Yeah, again, another great question, Randy. And obviously, as I mentioned, we're very focused on data, and we like to watch the data that comes from the training that we implement. We earlier this year, we developed a training program. So in 2024, we were trying to counter an increase in firm landings or at-risk or near-tail strikes. And we sent a team of subject matter experts to FedEx to observe how they developed and deliver perception, monitor, and response training, or PMR. That team came back to United, and we developed our own version of it tailored to our operation. We introduced that training in the first quarter of 2025 to our 737, 757, and 767 fleets, where we saw the highest prevalence of at-risk landings. We also communicated a lot of the information that we developed through this training development to all of our pilots, and we're preparing to launch that training for our Airbus fleet in the fourth quarter of this year as we take more delivery of long-body Airbus aircraft. But the idea with perception, monitor, and response, it's not about teaching pilots how to land. One, it's about providing the rules and tenets of a successful landing, and also introducing them to the visual cues of an at-risk landing. So, and again, this isn't just a pilot flying issue. This is a pilot flying and a pilot monitoring issue. So we're teaching them to actively monitor the aircraft during the flare and landing maneuver, to recognize the cues as they develop of an at-risk landing. And then we empower both pilots, the pilot flying and pilot monitoring, to either recover as they see these cues develop, or for the pilot monitoring to intervene if there isn't an appropriate response from the pilot flying. But it is all about giving the tools to these pilots for a successful landing and reduce our at-risk landings and tail contact events. Since the implementation of this training in the first part of this year, we've actually seen a drastic reduction in at-risk landings and tail contact events. And we haven't even implemented this across the entire fleet yet. So we'll watch that data closely, particularly as we implement this across the entire fleet and more pilots receive this training, but we're very encouraged about the data. Additionally, we're also looking at innovative ways to communicate and reinforce training that our pilots have received at strategic times. One of the ways that we're doing this is through utilization of the iPad lock screen. We saw a huge opportunity in that lock screen, and it's not just about pilots to post their ID pictures or their phone numbers in case they lose it. We saw this as an opportunity to communicate operationally relevant and safety critical information to our crews, where they're going to see it multiple times a day. So we first used this in 2024 to assist with our flight attendant turbulence injury rate. We saw an opportunity to reduce our injury rate, help our in-flight partners return home in the same condition that they reported to work in. And earlier that year, we developed a turbulence action guide. It was just a simple chart that our crews could reference either ahead of or in response to an unexpected turbulence encounter. So we deployed that turbulence action guide for the first time last year during a period of increased flight attendant turbulence injury rates. Immediately after the deployment on the iPad lock screen, we saw a change in pilot behavior. They were being more proactive about seating the flight attendants in advance of a turbulence injury or a turbulence event. And we actually saw a reduction of the turbulence injury rate. This year, we deployed that turbulence action guide on the iPad lock screen proactively ahead of what we knew was going to be a seasonal increase in turbulence injuries or turbulence events. So we proactively deployed it, and we actually saw a reduction in the turbulence injury rate during a period that we have historically seen an increase in the turbulence injury rate. So not only were we successful in reducing the overall rate of injuries, we effectively dampened out the seasonality, those seasonal peaks that we typically see throughout the year. And obviously, we'll continue to look for opportunities to strategically deploy information on that lock screen, but we've seen great success in the data through that program.
That's great. I mean, it's something that I had never even thought of or heard of. And so you mentioned that, I guess I'll have to delete the pictures of my dogs so I can get some turbulence info on there. So Bryan, you've been one of our subject matter experts on flight sim devices for a long time. You know about as much as anybody. There's some current ICAO guidance on qualifying training devices, for their use and trying to match, their capabilities with the training tasks, for the desired learning outcome that we're trying to achieve, right? So can you provide more insight on this method of qualifying those training devices?
Thanks, Randy. I'll try.
Perfect.
So I'm going to correct you. When I entered this type of work for ALPA, I knew nothing about simulators and flight training devices. That's 20 years ago, so I'm starting to learn a little bit. So 9625 is the name of the foundational document, which was the first global effort, and the mission was try to standardize and qualify or harmonize the qualification of all flight training devices that receive credit. So fixed motion all the way up to full flight motion. And this began in 2006, and it was chartered by the Royal Aeronautical Society Flight Simulation Group. So by default, the participants were heavily skewed towards the simulator engineering and device development side. So I was one of two union reps there representing pilots. The other was Captain Tanya Harder for Lufthansa. And as I mentioned, for myself, I didn't know much about training devices. I was a line check airman. I'd worked in the simulators, but I never had much formal training on the limitations or capabilities of these devices. But boy, did we take a deep dive in that effort. So imagine going to your first meeting, and there's all these probably 80 or 90 simulator engineers, professionals, most with advanced degrees specializing in visual systems, aerodynamics, force feedback, motion. We had representatives from all regulatory agencies around the world because this was a global effort. We had academic institutions, the NTSB, NASA, and very little representation from the pilot management or training side, people that actually deliver and evaluate using these devices. Luckily, our participation in that group, although we were quite intimidated at first, was very useful because they realized that they needed the actual users of this product in the room to help inform them of how we could qualify and standardize all these devices. So I'd say the outcome we were really happy with. So what was the outcome? Prior to this, it was typical in industry, I'm very much simplifying it here, they would deliver devices, industry, and they tell airlines, well, here's what you can use it for. And if a regulator signed off on that for credit, that's how you went about your business. This is a fundamental change in the way we did this. We actually ended up looking at every task from the private pilot license through commercial instrument, multi-engine, all the way up to specific type-rated training. And not just for the FAA, for EASA and all the other global regulators. So we drilled down very granular to look at the tasks, and we find out, well, what's the features that you need in simulation, and what's the fidelity of those features required to support that task. So an easy one. I want to train a pilot in how to enter or manage or exit a hold using a flight management computer. Our task trainer, simple device? Absolutely. If you wanted to do a wind shear or a V1 cut with a lot of physical forces manifest, That's a pretty easy one. But I want to give you a specific example how this worked in the 2.5-year effort. So we broke it on down by tasks. One of the tasks back in the day, before we had RNAV approaches and constant glide path approaches, we had to circle. And my old airlines, we'd have to circle because we didn't have straight and precision approaches with all kinds of terrain in a non-radar environment. So to circle on the line below 1,003, we had to do that in simulator. So now, what's the features and fidelity levels that we need to actually support that? And now the simulator is like, we need to hear from you guys. What do you actually do? They never really looked at it at that granular level. So we're looking at field of vision. I'm using the circling approach example. It's not 180 degrees. It could be cross cockpit. The first officer or the captain could be circling to the right or the left. And it's a little more expansive than 100 degrees because you have to have a maneuver within TARP's criteria to maneuver within the airport safely, according to the criteria. And you might have to adjust the flight path of the aircraft because of a crosswind. So based on this type of approach to supporting this specific task, we came up with a field review requirement of 220 degrees. And at the time, that was controversial because it was expensive. But we could justify it because that's what we needed to support the task. What we also did was we broke down the features of flight training devices into 13 major features. I'm not going to name them all, but I'll give you some examples. The features would be sound, motion, visual system, force feedback, aircraft structures. There's 13 of them. And then we broke it down, what level of fidelity do we need to support this training objective? So that was the work 20 years ago. And my main takeaway from your question is if we want to do this very well in training, the device manufacturers need to work with the airline and the training experts, particularly in the develop and the initial implementation of these devices, because they need to both understand what's the training objective, what's the ultimate result, and the end user is the line pilot. Now, there's 3 main components to an approved training program, because training has changed quite a bit since 20 years ago. 9625 is a document out there. It's still existent. It's on its 3rd revision. You can actually go into the tables and look at every training task, and you can find a feature and fidelity level represented in there. But that's not how we conduct training, because now we look for an approved training program, right? And the best approved training programs utilize data, like you so well mentioned, Sam and Josh. FOCA, ASAP, LOSA, AQP data should be driving your construct of training. You should be able to adapt it for the dynamics of your pilot group. And you should measure how that's being received and delivered all the time too. So really, you're looking not just at the task, which is fundamental, but you're looking at the approved training program and having that cross cooperation between the developers of the devices and the employers of the devices, the airline and the check airman. That's the ideal. Now, the 3 components of an true training program are the airline, or the training provider. It's the manufacturer of the devices, the quality of the devices, and then you have the regulatory oversight. So I'm going to use an example here in the States, and we'll call it the gold standard. Thanks, Josh. 64 devices. So let's say United Airlines would be the gold standard of an operator. A large airline that has its own training infrastructure. Here in the States, it'll be SMS-driven. It's entirely data-driven. They're getting that feedback. They had a confidence in the system that they can move and measure and always self-improve. Smaller airlines might not have their own training infrastructure. They might have to seek outside vendors to provide that training. The second component is the quality of the device. And so, again, United Airlines has selected fidelity levels that are well above what's required to the standard, but they see the benefit in doing that because you're seeing some return in value in what you're seeing with the data. And the last is the regulator. And at least in the FAA, it is a robust, mature, experienced organization. Now, I want to mention that as an example of the 3 components, because at ALPA, we work on global regulatory issues, particularly in training devices. So you can have those 3 components, and you can meet the standard, but let's contrast this how it might come out. Let's take an airline somewhere in the world that doesn't have its own training infrastructure. They haven't been around long enough. They don't have it, they haven't developed it, so they contract out with a training provider. That training provider might be chosen because of the cost model. That training provider might acquire devices that meet the standard, but they certainly might not be the fidelity of what United enjoys. And then the third component of that is the regulator. not all regulators have been around long enough to provide that level of expertise and observation of the program. So they all meet the standard, but the three components, the quality of the final end product greatly depends on that. And that's what we need to be aware of on the training committee.
So why is it so important to utilize the highest fidelity with motion to achieve the desired learning objective? Why is it so important?
Well, I got opinions on that. I could be pretty passionate about it. Just common sense. Pilots never cue out the ability to use all their physical, verbal, cognitive, communicative skills when they operate on the line environment. So the whole idea of simulation is to replicate the line environment to make it as realistic as possible. So I would say ALPA standard, well, it is, you and I have seen it, it's not just motion we're calling for the highest fidelity, it's all the cues that will assist a pilot in developing, maintaining, and improving their professional knowledge and development. So motion has always been the big target. So during 9625, the visual acuity for simulation was greatly improving, rapidly improving and getting cheaper. At the same time, there was some poor motion. And I would agree that poor motion is probably worse than no motion. But that doesn't mean you get rid of motion. You try to make it better. And it's not just the motion. The motion has to be harmonized with the force feedback model, the flight controls, and instrumentation. And if that's off, you're going to see it. It could even make you nauseous if you're in a poor model. But the goal, again, is always to improve it. I want to give another example of motion, because after 9625 was done, the next big activity for the flight simulation group was loss of control in flight. And that's where this whole UPRT started. That effort was started in 2009. And as part of that work, we learned, it's the flight simulation group for the Royal Aeronautical Society, we're looking at simulators and full flight simulators primarily. And we were surprised to find out that the aero models in almost all devices didn't go beyond initial stick shaker, which is not even full stall. It's getting some, it's getting some upset over the top of the wing, but it's still flying. But that was the limit. If you don't have the aero model, the mathematical model, then you can't replicate that type of behavior to pilots. So that was the whole impetus of, if we could obtain the model, if we could put the model in the devices with the OEMs providing that model, and we had to tune it with subjective input from flight test pilots that actually stalled the 737 or whatever model we used. It became a regulation in 2019, but I use that as an example of continuous efforts in ALPA to improve motion, to improve fidelity at all levels, pays benefit to the line pilot. So I hope we've had good feedback, because it's been a rule and only in the United States since 2019.
So what are some obstacles in adopting some of these new training device technologies into our currently approved training programs?
Well, I've got a couple, but the primary one, and this is interesting to close out this week with this topic, it's the quantity and volume and the rapidity of new technologies that'll be flooding into the pilot training market. It's artificial intelligence, it's extended reality, and my concern is, if an airline works with a good provider in concert together that's supportive of specific training objectives, you can have a good outcome. But when there's a vacuum in the market, these good devices will probably be followed by manufacturers and devices that just meet a standard, their check-the-box approach, and they'll be deployed in a way that's not thoughtful and data-driven in the future. So, if I could talk a little bit, this is kind of shocking because it just happened at Alaska Airlines, March or April. We've been using extended reality, the head-mounted goggles, for pre-flights and flows, and it's been very well received by our line pilots. It works great. A press release came out from Alaska Airlines, our director of training, and our investment arm, that Alaska Airlines had partnered with the company, Loft Dynamics out of Zurich, to deliver the first extended reality full flight simulator. And in the same announcement, they trumpeted, because this is not just a cooperation, a contract to buy devices, this is an equity investment of Alaska Airlines in a device manufacturer. So it's an equity involvement. So he's speaking in this press release not so much to line pilots or ALPA volunteers or speaking to investors. This could save us a lot of money because we could replace full flight sims, and we could put these devices, because they're about 1/3 or 1/10 the mass, depending on the configuration of a full flight sim, and we can put them where pilots are, and we could save travel time, or they could come in for more repetitions, and they're way cheaper to operate. No argument there. They would be cheaper. So there's a good side of this. So they got my hackles up a little bit, and luckily, Randy, thank you, and Todd, ALPA leadership supported me going over to Zurich to fly this device. Now I want to be careful because it's a 737 MAX 9 device. It's probably going to be ready for beta testing in about March of next year. This is how quick this is coming. What I flew was what something Loft Dynamics has been doing for about 8 or 9 years, and that's a helicopter version with full motion. So they started in the H-22 or the R-22, the Robinson, and they moved up to the H-125 and 145, so turbine multi-crew helicopters. And there really wasn't that background of full flight simulation as much as in helicopters. So they actually met a need. I could tell you a really interesting story about how the founders even got into this. But so I've never flown a helicopter. I've never flown a helicopter simulator. I was totally impressed by this device. First off, I'll describe it. I did have slides there, but weren't able to put them in. It's a motion platform, and you use head-mounted display unit, each pilot. And it's designed to be multi-crew, obviously, for the 737. And it's got the collective and the stick, and they calibrate the heads-up display. So they spend quite a bit of time at calibration because they have to measure. So my arm holding the collective and the stick has to perfectly match what I'm seeing. So I am holding a physical manifestation of flight control and collective, but everything I'm seeing through the heads-up display is virtual. So I'm seeing the collective and the stick, and I'm feeling the really thing, but I'm seeing a virtual representation. I see my hand, but it's an avatar of my hand. Really interesting. But the quality of that virtual was unbelievable. And having never flown a helicopter before, after about 45 minutes, this device was so good, particularly in the motion cueing, that I had a lot of confidence. If I use this device, I could really accelerate from zero-time helicopter and have really valuable training. So these are the good parts of the story. I'll get to the cons here in a little bit. So I was expecting really good motion because the weight of the device is so much lighter than a full flight sim that you can get the motion cueing to be really good, particularly in the yaw and the rudder aspects. So let's talk about the cons about this that we know about. Physical limitations. You mentioned you had some pilots getting a little bit fatigued after 20 or 30 minutes, right? So we've seen some of that. Well, imagine doing this for a 4-hour session, okay? That's an issue. The peripheral vision part of this was interesting. I found myself, the limited peripheral vision, this head-mounted display, I could focus on the primary flight displays, the engine instruments, the outside visual, wherever, but that was about it. So you're very limited on the peripheral vision part of it. And then the weight of this too, and fatigue issues, they're getting lighter. They're probably going to get more visual wide scope angle in the future, but those are concerns right now. And then the instructor. The instructor is remote, so they're not directly in the device. Oh, we need to mention this. Your partners, Josh and I are flying together. We're in this device in the future, but I see an avatar of Josh. He sees an avatar of me. So we know that there's a lot of nonverbal communication that goes on when you evaluate and train CRM. We know, particularly lately, thanks to your work, Samantha, the pilot monitoring aspects. We're really emphasizing that as an industry and at airlines to be an active pilot monitor. And some of those are visual cues. The whole point is there are things we don't know how we're going to address that in this expanded reality device. These are unknowns. I'm coming up on the time here, but my point is this is coming really quickly. So you asked me what are the challenges? Number one challenge is that the rapidity of this is coming and the volume it's coming. And we need to be prepared as an association to represent our pilot interests in training And so one way we do that, and I think it's the only way to do it that I've seen, we've talked about this, Josh, it's a data-driven approach. Implement it gradually. Take the data and look at things at how this is evolving. And I'll even say this, Josh and I could probably sit in an extended reality device when it's delivered. I don't know when it's coming fall next year. And after 2 or 3 sessions, we might just nail it. We fly your loft scenario or our LOE scenario. We do a great job. But at the end of the day, what we showed was we're proficient and passed the standard doing this. And not like we really would out on the line. And I'm just being agnostic. I'm not saying there may be, I absolutely believe there are benefits to extended reality. I just think we need to be measured and careful. Analogy for medicine. First, do no harm.
Absolutely. And as we wrap up, and thanks, Bryan, that was amazing. As we wrap up here, if anybody has any questions, please do make your way to the microphones or send some Q&A to the apps here. And the main takeaway, full motion simulators remain the anchor and the benchmark for our training fidelity. And the bar is evidence. Right? Show that transfer to learning LOE performance and ultimately, line safety. And if we can't do that, then it's just an experiment and not a program. We'll take a couple questions right here in the middle.
Thanks, Ryan Mitchell from Air Canada. I appreciate the conversation about all the technology and specifically the thoughtful approach to incorporating that technology. I really appreciate Samantha's discussion about pilot professional development and incorporating that into the training footprint. I'm wondering if anybody has explored or is applying any other some organizations are using things like sports psychology or other aspects to help people prepare to be effective in training. So new hire stuff that looks at accepting feedback and using it effectively, helping people train themselves beyond just the existing footprint that they're getting. So it's a bit of, preparations or form training as part of the whole training experience so they can take that and leverage it more effectively than just the allowed time in the training footprint. So stuff like resilience and, again, using feedback, things like that. I'm wondering if that's anything that's been explored or you've seen explored through your views.
If I can, and I know we're running short on time, so I'll give you the shorter answer here. At United Airlines, we use training called resiliency training, and that allows us to introduce a number of different aspects, but it includes briefing, debriefing, coping with and reacting to startle responses, how to shorten the time that a crew perceives and then responds to an input. But yeah, we have seen really good success at incorporating that. We incorporate that from the very beginning stages of training, so during our basic in-dock training.
And it will be available after the closing remarks. We're here all evening, so please come and find one of us. We are very passionate about this, and we will talk your ear off about it. So thank you to our panelists, and thank you, Stacy, and thank you everyone for having us up here today.